How many people are enrolled at the moment? $265 as of yesterday. This room holds for 20, I believe. Or 416, something like that. So maybe most people are here. It's good. I think it'll be a good use of your time today. So we can get started. This assignment is one that's typically it's a lot of students think this is the hardest one of the first half of the quarter. So if that means anything, all of them are meant to be challenging, and they have different levels of challenge. Definitely, some things are easier for other people, what have you. So this assignment is a circular linked list, as you might have guessed, and it's a polymorphic generic container. And these are the functions. It's all in C only, and these are the functions you'll be writing. So let's see what the level of effort is. Advanced next list will be a one-line method. Advanced pre-list is a one-line method. Check to go forwards. When you do an insertion, you'll be either inserting at the beginning, the end, or anywhere in between. And so if let's say the list has 100 items, and you want to insert at position 80, it's better to come from the end than to come from the beginning. So that's the idea of check to go forward. It's like you say where you're inserting. That's what this where value is, which list is it that you're using. And then you need to decide, are you coming from the beginning of the list or the end of the list? So that's what that is for. So that'll be an if statement, a loop. I think a loop and an if statement, or probably. So this isn't too many lines. This isn't too bad. 10, maybe less. Delete list, we'll talk about that in lecture. So find location. This is a method that finds the location in the list to do your insertion. Right? The circular linked list will achieve the same goal of inserting at the beginning, the front end, or anywhere in between. You need to figure out where is that position in the list to insert. So that's what this method does, find location. And then this is the insert for the list. And then which will be no loops. There'll be, this is going to be, I don't know, 10, 15 lines possibly. So you'll be spending a certain amount of time here, a certain amount of time in find location. I'd say this is the majority of where your time will be. Because empty list is a one-line method. We'll go through new list today. That's your constructor method. And then remove list is the opposite of insert, so it has about the same number of lines. View list is very similar, but you're not taking an action on the list. Write reverse list, we'll have the write list, that function. So you can look at that. This one shouldn't be too bad. So we've got 1, 2, 3 one-line methods in list. This one we'll handle today pretty much. Really the main effort is find location and insert within this code. And then there's node code, and we'll be helping you with insert node today as well. So hopefully this one won't be so bad. Remove list is the opposite, 4 or 5 lines. View node, I think, is another one-line method. And then typically you don't do any documentation to code you didn't write, but this time I would like you to write the function headers for the stack methods. Even though the code is provided, we want you to remember we're still implementing a stack. And the description, as we'll look there in a second. Here's all the descriptions of all the methods, and we'll go through them as we talk about the assignment. So So let's look at the layering that goes on. So let's start the driver code. In order to test out the list, we need a sample object. So we use something called MyRec. Stands for My Record. It's a structure, the simplest one we can come up with. So a simple structure is a simple object that has a data field, a long XXX. And then we need to have a constructor for that. Here's the new MyRec constructor that allocates size of MyRec, casts to a MyRec pointer, stores a new variable called this MyRec. Then that does the allocation, this is the initialization, and then we return. To deallocate, we free up the pointer dereference one time, assign that pointer to 0. To write it out, we say MyRec has a value of, and we print out the XXX field as a long decimal. So this is the write function, the delete function, the constructor function for a MyRec object. And this is in driver 1 that stores the original. Driver 2 stores a copy that the list makes. So here's the copy constructor. And so what do we do here? We allocate the size of the MyRec, and we assign the XXX of our parameter object equal to this MyRec XXX field and return it. The other methods are the same. So this is driver 2. So the first driver is driver 1. We create a MyRec element, a pointer to that, and that's what we're going to pass to insert. So in insert, we say, please enter a number to insert into the list. You call decin to read in that number, create the new MyRec, and then we insert into the stack that element, whichever one you just created, and then from where says front, end, or anywhere in between. That's what that says. So you're saying where you want to insert it to the list. Earlier on, you had to create the list, which is done here, new stack. So your driver for homework 3 had a main stack. This is the same thing, new stack. New stack takes 3 parameters. These are function pointer parameters saying this one, the first one is how to make a copy of the item that you're storing. Since driver 1 doesn't make a copy, we pass in 0. We don't tell the list how to make a copy. Here's the destructor, how to destroy an item, and here's how to write one out. So we tell the stack how to do those manipulations. In driver 2, it's very, very similar, except driver 2 is making a copy. Right? Driver 2, the list itself makes a copy, so we pass to the new stack constructor the function pointer, how do we make a copy of that item in the list? How do we delete that item in the list? How do we write out that item to the list to the user? So these are the 3 manipulations we're going to be doing. And so other than the copy function, it all seems about the same. Seems about the same, but it's a little bit different. Here's the reusable element, MyRec element. It's not a pointer anymore. In homework, in driver 1, it's a pointer. In driver 2, it's a reusable object. Since we know we only need 1, we know that at compile time, we allocate it on the runtime stack. So that's that one being allocated. So that's the reusable space. When we call insert, please enter a number to insert, and we assign that reusable space's XXX field to the value of decin. Then we insert into main stack the address of element, which is the address of our reusable space, and then we say where we're pulling from. So those are kind of the differences between driver 1 and driver 2. Driver 1 stores the original, there's no copy function, there's only 1 item ever. Driver 2, there's 2 objects, right? The reusable space that we pass in the address of that reusable space. This is kind of like the photographer's chair, right? We pass in the same address again and again and again and again. The difference is the values change with every call. So we call the insert function directly, or we could have called push. So the first layer is the outer layer, the driver code is the outer layer. Then the next layer is the stack layer, and the stack layer is here. Here's stack.h. We're saying stack is the same type as a list. And then here's your stack methods. Delete stack is empty stack, new stack, push, pop, write stack. So these are basically the same functions, very similar prototypes to homework 3. The new stack looks a little bit more complicated. It has 3 parameters, and it looks a little daunting, but really, we know how to read these, right? We go to the name or innermost set of parentheses, copy func. What is that? We get to the closed grouping parenthesis, and we go back. So copy func is a pointer to what? We go forward. Function taking void pointer. We're at the end of the declaration. We go back. It returns void pointer. Delete func is a pointer to a function taking void pointer, returning void. Write function is a pointer to a function taking 2 parameters and returning file pointer. And we passed in the right parameters. We showed you the call to new stack. We're passing in copy myrec, delete myrec, write myrec. Or we're passing in 0, delete myrec, write myrec. So this is the constructor function, and you've got your destructor, all of these things. And what do all these methods do? Here they all are in their complete implementation. You just delegate to list methods. How do you delete the stack? Well, you delete to the list. How do you check if the stack is empty? Well, we check if the list is empty. How do we create a new stack? Well, we create a new list. How do you pop? You remove from the end. How do you push? Insert at the end. How do you top? You view from the end. How do you write out the stack? You write out the list. So the stack is just really a facade. A facade is something with a false front that does nothing. It just serves as an extra layer. The calculator needs a stack. Calculator needs to push, pop, top. Calculator doesn't need a list. Calculator needs a stack. So we have a stack, but the stack is just a facade. That's a design pattern of just creating something false for appearance or for an extra interface, but it really doesn't do anything. And all the methods are implemented via delegating to list methods. We're just passing the buck. Okay, you do it. How do you delete the list? Or how do you delete the stack? Well, you do it. You go and delete the list. So there's really no logic here. It's just calling the list method to do the logic. The next layer is the list layer. And so the layer of list is, here's your list object, or here's your list methods that we showed you in that first, in the main handout. And debug on, debug off, I think you're familiar with those. Here's some constants for you to insert at the front or insert at the end. To view, remove, insert at the front or the end, so that'll be helpful. And we're saying struct list. This is a declaration of a structure, but there's no definition. This allows us to create a pointer. Doesn't allow us to instantiate any lists. So here we can pass in pointers to our list functions. They all take pointers to lists. So the compiler knows what a pointer is, but it doesn't know what a list is. So the list implementation is hidden, private. This is the .h file. The .c file has the definition of the node. So this is a private type. It's not known in the .h file. And we've drawn this in class. Pre, next, and data. That's what we expect. And then here's the list. We're going to have an end pointer, a list count, saying which list is it, list 1, list 2, list 3, list 4, list 5. Occupancy, how many items are in the list. And then here are those 3 function pointers that say how to copy an item in the list, how to delete an item, and how to write out an item. Here's all those methods that we showed you earlier for the nodes, check to go forward, delete node. So these are the things you'll be doing. Here's your catastrophic error messages. Here are your debug messages. So you can use them similarly. And here's all the code. Your code goes here. How would we write out the list? So we write out the list by starting with the driver code. The driver code would say the stack contains, and then we call the write stack method. The write stack method would do what? The write stack method is going to delegate. It's going to call the write list method. So here's the write list method call. What is write list? This is provided for you. So this is example syntax in C, example kinds of things to check, how to use that data structure. So we look for write list, which is here. Here's the write list function. We pass it a list pointer, file pointer. This is going to be standard out, standard error, right, that we're used to. And then this is how many items to print. So this is some kind of a counter, and here's our working node. Then we have our validity checks. Did we pass in a non-existent file, like stream was null? Or how about this list was null? Once those things are fine, then we check, are we debugging? This is something unique to the write method. Are we debugging? If so, we give a little bit more information, and then we say, we're printing out which list number it is and how many items are in the list. Then we check, do we know how to write out an item in the list? This list is like the this pointer in C and Java, C++ and Java, right? But this pointer, it's the pointer to the current list whose number method is executing. And so we're saying the list write function, is that 0? If it's 0, we don't know how to write out anything that's in the list. So this is another validity check. Then we check if the occupancy is greater than 1, that means there's actually something in the list, and then we start the working pointer at the one after the end. So what's the one after the end? Circular linked list, the one after the end is the first one, the beginning. This list points to the list. We have an end pointer that points to the last node, and then what's the one after the end? That's the beginning. So this sets up the list to point to the beginning. And then we go through a for loop for 1 to however many items are in the list, and then we check, we say, are we debugging? And then we give more information. Then we call write node. So this would be the next layer, right? We start out with the main method, calling write list, calling write stack, and now we're in a loop of calling write node. So we pass in which node is it that we're writing out? Are we writing out to standard error, standard out? And then how do we write out an item in the list? We call the write function. So where's the write node? Here it is, doing your validity checks. Again, your parameter, this is standard out, standard error. This is the current node executing. And here's the write function. So we check. Do we know where we're writing to? Is there a node that we passed in? Is there a write function? Okay, if there is, let's dereference that write function pointer, and we'll pass it the data to display, and we're displaying it to standard out of standard error. So with the driver code, this is going to call the write myref. That's what the write function will be. Why is that? It's because that's what we passed in the main method. I thought the name was at the beginning. At the beginning, we passed in copy myref, delete myref, and write myref. So these are the functions that will get called by the list code. Okay, so that's an overview. Let's show you the testing of this. Always too many items on my desktop. Okay, so let's go to the public area. Homework 4 is due tomorrow, so I'm hoping you guys are almost done with homework 4. In homework 4, you ran the calculator. A good test would be like 1. 1 should return 1. 1 plus 2 is another good test. How about 1 plus 1? Is that a good test? It is, but it's really not. What's wrong with the 1 plus 1 test? You don't know which one it is. Right? There's two numbers of 1. So when you're debugging and printing things out, you don't know which one you got. You really want to test with distinct input. Also distinct characters. So 1 plus 2 is a much better test case than 1 plus 1. So anyway, we're going to homework. So we run driver 1. And what do we want to do? We want to, let's do this. Let's insert 1 at the front, insert 2 at the front, insert 3 at the front, insert 4 at the front, insert 5 at the front, insert 6 at the end, insert 7 at the end, insert 8 at the end, insert 9 at the end, insert 10 at the end. And then we write it out. So we inserted 1, 2, 3, 4, 5 at the front, the front, the front, the front. And so this was the last one we entered at the front. So there it is. 5 is at element 1. Then we entered 6, 7, 8, 9, 10 at the end. What would you say about this test case? Any observations?
Whole number?
Everything's going to be a whole number. There's something really unique and desirable about this test case, and you want to strive for that with all your test cases. What is it? Any guesses?
It tests the list in all directions.
You're listing both directions. I think it's easier than that. You're thinking too hard if you don't really know. Or maybe you don't realize you know. It's not random. It's algorithmic. These were deliberately chosen numbers in this sequence. It was very deliberate.
All numbers are different.
All the numbers are different. Very good. But it's 1 to 10. What does that mean? It's familiar. It's familiar. Like, let's say I ran this test case and I said, well, let's run, test the list. So let's insert a number. What number? 15. Maybe I do that at the front. In the next case, how about 25 at the end? How about 37 at position 3? How about 94 at position 5? How about 67 at position 1? So maybe that is a good test case, but when you look at the output, you have to refer back to a reference. How do you know which item was first, which one was second, which one was third? How do you know which one was inserted at the beginning, which one was inserted at the end? So having the output where it's so familiar, where we can just say, oh, 1 through 5, 6 through 10, or maybe 1 through 4, 5 through 8, that would work just as well. This shows you, we can just look at this and say it's right. We don't have to spend any time really verifying and checking what did we do to give us confidence in this answer. And then this checks all the the next pointers. The list is going one to the next, to the next, to the next. And then writing it in reverse checks all the pre-pointers. So if I were you, I would do these methods help you verify your code is correct. Sometimes, I gave you the right method, you guys write the right reverse method. It's very, very similar. And some people wait until the end to write this. And it's like, I don't know why you wait. This is going to help you verify that all your pre-pointers are working. Just because you write it out and it works fine going forward, that doesn't do anything to verify your pre-pointers. So I would suggest having write reverse list as one of the early methods to work on. That way you just have more infrastructure to verify your testing. But this test is really a nice one. It's familiar. And we're going to strive for that in other things that we do as well. We'll look for familiar results to just say, oh, we'll look at that, oh, it's familiar, I got it, it works. Here's, and then we do control D. Let's do another test case. Driver 1, and then we enter, let's push 10, let's pop, and let's push again. And we write it out. Seems simple enough. A lot of you will fail this test case. It's not as easy as you might think. There's something about it, but I think that you need to think more about the assignment. But a lot of you will have this problem where it's not gonna work, it'll break. Another one is the calculator. 1 plus 2 times 3. There we go, it still works. Many of you, the calculator won't work anymore. You might run through all your tests and the list works fine in driver 1, the list works fine in driver 2, and then the calculator fails. So that will be, I'm not sure how common, it's not uncommon, definitely. Why would that be? You test the list with driver 1 and driver 2 and it all seems fine, and then you test the calculator and it's broken? Bug in Gary's code. Because the calculator code is going to be supplied. If you don't get the calculator working, it's not that big of a deal. Turn in what you've got, definitely. Hopefully you get it working. But right now, the calculator code is without permission. Calc.c, no permission. So once you turn in homework 4, we'll turn on permission to Calc.c. You can use your own calculator if you want, but you can use mine as well. So if you didn't get the calculator working, it's not such a big deal. But anyway, driver 1 works, driver 2 works, Calc doesn't. What could be the problem?
So when we're importing the file over to our system, it's going to give us a content right away, right?
If you say make directories, make install, it'll give you an error because Calc.c has no permissions. All the other files will get copied over and you can get started. And then you can move your calculator.c over and or tomorrow after the deadline you want to get started, make directories, make install should work fine. So anyway, any answers to my question? The calculator uses the list in a way that the driver doesn't. That's why. What happens in the driver? It uses one list and you test everything as much as you can. What happens in the calculator? There's 2 lists. You pop from one list and you push that item onto another list. So that's a different use of the stacks. It's a different use of our lists. The driver programs don't test that. Testing is hard. Testing is hard. So anyway, I think if you run driver 1 and you run driver 2 and there's no problems with make Valgrind, then the calculator should probably work. Typically the problems you might have is with memory, memory leaks or some other kind of memory violations that cause the calculator not to work. And let's just run the driver with -x and then we should start helping you with some code because we're going to run out of time. Driver 1 -x. Here the list has been allocated, so let's insert 1 at the front, and then insert 2 at the front, insert 3 at the front. And so you get the debug messages, so you see what's going on. Your debug messages don't have to match mine exactly. You may have a different implementation than I do. So the point is never to match my debug messages 100%. You want to match them generally. Like if I have debug messages and you don't, that'll be a problem. If I have them for insert, lookup, and remove, and you have them for insert only, that'll be a problem. But if they don't exactly match up, whatever, your implementation may be different. So I'm not asking you to try and match up 100% those debug messages. If you want to do that on your own, it's not something I'm asking you to do. The debug messages are there to just help you to better understand what's going on behind the scenes. They don't have to match. I don't know what more to say about this, so we'll say Control D, and then the list has been deallocated. Okay, so let's start writing a little bit of code, and then we'll have a drawing, and then we'll write a little bit more code. And then, just like usual, we'll be doing some more talking about homework 5 in class tomorrow. Homework 5 is fairly sophisticated. Maybe you're all silent wondering, gosh, I'm not sure what's going on quite yet. And so you will, and we'll spend more time, probably all day. All of our lecture tomorrow will be spent going through the assignment and, looking at various things about it. There's a lot of nuances, a lot of clever things, and, the layering and everything else. So anyway, let's do the new list method. New list should return, of course, a list pointer. Function is new list, and we take in the three function pointer parameters called copy func, and then I put them all on a line by themselves so you can more easily see, separate them out. So the three parameters are on lines by themselves. And I don't know that it matters what all the prototype is for our example. Maybe this makes it a little easier, just not looking at all those extra symbols. I don't know. So this is our constructor. So what do we do first in our constructor? We allocate. So how do we allocate? In any constructor in C, we would do the exact same thing. You've done it in homework 3. How do we allocate a list? We declare a pointer variable, a list pointer. What's the name of our variable? This underscore list, or this list, something of that sort. And then we're going to assign this equal to what? Hey compiler, we know better than you. We're going to treat this as a list pointer. And then we say how much we want. Malloc, how much? Size of what? List. So that's familiar because or it should be familiar because that's exactly what we've been doing. We're being consistent. And then we initialize. So initializing, this list arrow n is the first field. There's 6 data fields of list. Can someone close that door behind us? Thank you. Here are the 6 data fields of a list. The n pointer, and then you have the list count, with list physic, list 1, 2, 3, 4, etc. The occupancy, and then we have the 3 function pointer parameters. So those are the 6 assignments we need to make in this method. This list arrow n equals what? A brand new list, where's the n pointer? Nowhere. No. 0. This list arrow list count. What is that? I'll let you do that one. This list arrow occupancy. What was that? How many items are in the list? 0. So this should be fairly straightforward. There's 3 more. This list copy function. That's the copy function pointer. How do you initialize that? Well, look, there's 3 parameters to this constructor. One of them is called copy func. We have consistency in naming. Any guesses what we put here? This is the copy function pointer field of the list. Lists copy func field. We assign that equal to the copy func parameter. Copy func. That's the parameter. This list arrow delete func. What is that? We have a function pointer parameter called delete func. And I'll let you do the last one. And then after we're done with this, then we say what? The function ends by saying return. What are we returning? This list. So there's your constructor function. Very little for you to do. Any questions on this? Yeah. What do the arrows mean? The arrows mean that this list is your pointer to an object, and the arrow means let's access the field of that object. You can think of it as the equivalent to a dot in Java. Like this was dot .n, well here you have a pointer in C, so it's this arrow. Any other questions? So, let's go ahead and talk about the list code itself. The list insert. So the list insert code is here. Inserts the element into this list at a location where. Find location should be used to locate the node at location where. This function should then call insert list to incorporate the node into the list. Returns 1 as successful, 0 for failure. So it's really as straightforward as this. The code begins, you need to call find location. Find location will then call check to go forward, and then it'll return back, find location will go forward or backwards to the right location. Once you got that location, then you call insert node. So that's exactly what you need to do. There's no loop. You get into this function called find location. When that returns, you call insert node, and that's it. So it's fairly straightforward. Let's say insert node. What does that do? And then we'll draw the picture and write some code there. Creates a new node to hold element. If copy function is not null, it'll make a copy of that element. This node is then incorporated into the list after this node pointer. So we're passing in a parameter, and you can imagine that that's the end of the list. And so we're always writing the code to insert after that parameter pointer. And the values of this node are expected to be a pointer after to which we wish to insert that new node. And it doesn't tell you here, but if you pass in a null pointer, then it's the first item in the list. Somewhere it tells you this. I'm surprised it's not here, but it's not. So the values of this node are expected to be that node pointer, or it could be null, meaning it's the very first one in the list. So why don't we draw some pictures on the board and then write some code. We're running out of time. Okay, so let's start here. Here's your runtime stack. You've got this node is one of your parameters. And let's say it's 0 to begin with. And the element is the parameter to point to the data. And let's say it's driver 1. So let's point this here, and let's point it to, all right, let's be consistent. We've been drawing this like this. So let's say that's the number 1. Then that's what your picture is. So your code, you need to allocate something called like this node. And that needs to point to a brand new node. And here's your new node where the data is going to point here. The pre-pointer points back. The next pointer points forward. And this value is returned. And back in the list, it captures that. And you need to capture that. And where would it get assigned? Where would the return value? The return value would be this node. And what do you do with that return value? Send back this node and it goes where? Somewhere in memory through some list item. There's a list with an end pointer and so back in the list code. Back in the list insert. to capture that value and assign it to your given pointer. So how many pointers are changing? This pointer is set by the new node constructor. So you don't have to do anything there. These pointers you need to change. So this needs to be set. Let's say this is number 1. Next needs to be set. So this is, let's say it's number 2. And you're assigning it to this node. So this needs to be set as well. Let's say this is number 0 because that needs to happen first actually. So let's not put it on the stack, we'll just say it's 0. So what would the code be? Node pointer, this node. You have to declare that. And then however much code later, you'll be saying this node equals new node, passing the right parameters. And I'll just say here parameters. And this is number 0. Then after that's done, this node, you have to start with a name pointer. Here's a name pointer, this node. We want to know what is this space. This space right here in memory is this node, arrow, pre. This node, arrow, pre. Where does it point? It points somewhere. We have to look at some pointer that's coming into this node that's already set. And the only one that's coming in here is this one right here, and it's called this node. So this node, arrow, pre, you want to assign to this node. This node, arrow, next. Is the same, this node. And this is number 1. This is number 2. So this is some of the code that goes inside your insert node method. Are there questions about this? Okay, so let's go on to every other case. And hopefully we'll have time to do this. Here's our runtime stack. We have element, this node. Oops. We have 2 things called this node, so that doesn't work. So how about call this one working? If that's called working, you guys didn't correct me on that. All this would just be working. Here's our runtime stack, this node. And then we have element again. And we have a working pointer. So this node is going to point into a list. And so the list is going to have multiple items. So the previous pointers point back. So it knows how many items are here. The next pointer points forward. This comes around. This one comes around. And this one goes here. And then here's whatever you're going to store in here. So this is the beginning picture. You have this node pointing to some node in the list, and you're going to insert after that node. Okay, so this is the initial case. This is every other case. So we want a brand new node. Working needs to point there. And your parameter element points to the data here, whatever is in there. That's the beginning picture. Let's say this is number 0, and the code for 0 is really the same. Working equals new node. You pass in your parameters. Same thing. Then you want to attach and integrate, like we did in class with the humans, right, with all the tutors. So you want to attach first. So attaching is taking the previous pointer, pointing it backwards. So this is number 1. The next, you're attaching, and this needs to go back over here to this node over there. This would be number 2. So we need to write the code for 1 and 2. So code for 1, we need to figure out what is the name of this node. We need to start with a namespace. The namespaces are on the runtime stack. So the namespace of this node is working arrow pre. Working arrow pre. And we need to assign that equal to something. And this, of course, is going to be working arrow next. So what is working pre equal? Working pre points here. What is the name of this node?
This node.
It's called this node. Very good. This was this node. And then what's the name? This one's here next. Points over here. What's the name of this node? This node next is that one. Okay, and then we integrate. Two more lines, 2 more drawings. So we integrate, we need to change this pointer to point here. Let's say that's 3. And then the 4th one, we need to change this pointer and have it point here. So that's 4. What is the name of this space? It could be this node next. Equals something. What else could it have been? Working arrow pre. Working arrow pre arrow next. So you can pick one of those 2, and that's going to be equal whichever one you want. It's the same. And where does this thing point? It points to this node, which is called what? Working. Last one, and then we'll be done. The 4th pointer is over here, this space in memory. What is this space called? Starting with this node, we've changed this one now. So it would be this node, arrow, next, arrow, pre. So we could say this node, arrow, next, arrow, pre. Do we have 2 minutes? This node, we follow this arrow here, and we updated this pointer. So this is the next, and then we have another next, and we're assigning it a pre pointer here. So this arrow, next arrow, pre. I believe this is correct. Or we could get there more easily by saying working arrow, next arrow, pre. Either of these are going to be equal to what? They both point to this node, which is called working. So there's your insert